In this question, we are given a solution to a given differential equation. So in yellow here, we have the solution to this differential equation right here. Our solution contains these constants, C1 as well as C2, and our job is to find the value of those constants given this set of initial conditions. We can begin by writing down the solution to the differential equation. And then we're going to take the first set of initial conditions right here. If we look at that very carefully, we can see that the value of t is going to be 0 and the value of x is going to equal -1. So basically, we'll just plug -1 in for x as well as 0 in for t. Now, this equation will actually allow us to solve for the value of c1 because we know that the sine of 0 is 0. So c2 times 0 is also 0. This term drops out of the equation. We also know, of course, that the cosine of 0 is equal to 1. So this becomes c1 multiplied by 1, which of course is still just c1. So there we have it. c1 is equal to -1. Next, we need to find the value of c2. And of course, we'll use the second condition to assist us in that. We look at the second condition. We can see that the value of t is once again 0. And this time, the value of the derivative, notice it says x prime here, not just x. The value of the derivative x prime is equal to 8. So this means we're going to have to take our solution and we're going to have to differentiate it with respect to time. So let's come down here below and do that. So here we go, we're differentiating. We all know that the derivative of cosine of t is negative sine t. So this gives us negative c1 times sine of t. And the derivative of sine of t is cosine of t. So we have plus c2 times the cosine of t. We can plug in the data that were presented earlier. Remember that x prime was 8 when t was 0. So we will fill in 8 for x prime as well as 0 for t. We're going to end up with another sine of 0 as well as another cosine of 0. From earlier, we know sine of 0 is 0, so this term drops out. Now we have 8 is equal to c2 times cosine of 0, which is just 1. c2 times 1 is just c2. So we can see that c2 has a value equal to 8. So now all we do is go back to the solution that was given in the question and plug in those values that we solved for. Here is the solution. Remember, the value of c1 was -1, so -1 times cosine of t is just negative cosine of t, and then the value of c2 is 8, so we have plus 8 times the sine of t. And this becomes the specific solution to the given differential equation.